Oh, there. Okay. We will go to the next topic. Okay, which is intrusion detection. Okay. Here I provide some papers. Of course, some additional material. You can take a look at it. But basically, I will go over the first paper. Okay, I think that describes some very important and basic concept of intrusion detection. Okay, before we start doing that, okay, there are some data right here. For example, also machine learning for that cybersecurity, something like that. Those are very interesting data set, especially for cybersecurity. So if you have time, take a look at it. It might be very useful if you want to do some security related project. Okay. So let's take a look at the first one, an introduction to intrusion detection. Okay. So basically, I wish you can download this PDF file and make some note. Okay, if possible, make some note. Okay. All right. In this paper, okay, we'd like to show what is intrusion detection. Okay. Of course, when we talk about intrusion detection, they are mainly focused on some security-related problem. However, I believe this is not only useful for cybersecurity or security problems, because in current data analysis problems, some problems are related to detection. So from my point of view, if your problem is related to detection, for example, this data point is, for example, is an attack or not. Okay. This product is function normally or not normally. This product, okay, is good. It's good one, or it is failed to function, or it is broken, something like that. You can collect a lot of different data from, for example, factory, from production line, from financial data. Okay, something like for example, this person is for example, we do some kind of prediction. It can for example, if you do some lending, okay, if you're a lending club, if you lend some money to someone else, he or she can return your money on time or not. Okay, those problems are basically falls into the category of detection. Okay, but when we say intrusion detection, they are more likely like we like to detect an intrusion or like to detect a threat. Okay, so but fundamentally they're basically the same. Okay, so basically when we talk about intrusion detection, okay, they try to detect intrusions, okay, attempt or a threat that potentially possibly do something harm deliberately to your system. So basically if we can detect those intrusion as early as possible, so that then we can protect our system. So that is the basic concept. So the need of the need of the computer system, okay, you can see that there is a very specific terms used here. The confidentiality, the integrity, the assurance. That means your system should be available right there. So if there's any attack, hackers attack your system to make your system unavailable, then you would believe that this computer system fails. Okay, fails. Okay, so let's go back to right here. Okay, usually we need a system to help us to protect our computer system or our network. So that is called intrusion detection system. Okay, sometimes you will find another term which is called intrusion protection system. Intrusion detection system means there's something wrong to your system, and you set up the monitor. Okay, so the monitor is right here. Okay, you set up the monitor. You monitor what exactly happens right now in your system, computer system or network system. So you collect those data from your monitor. Those data sometimes we call audit data, right? So those data, and you feed those data into a decision support system. Okay, decision support system. And such kind of decision support system will make a decision according to your current observation from your monitor, right? Such kind of decision support system can be a neural network, can be a support vector machine, can be a simple regression or logistic regression algorithm. Okay, so we collect the data from the monitor, which is audit data or observer data. Okay, we feed them into a intrusion detection system. This detection system has a core function, which is to do the decision support. It can be made by neural network or any other machine learning algorithms. Okay, so that is, you make a decision, but there is a very interesting and sometimes a debate or something that if your system monitor your if you have a monitoring system and it monitor your computer system or your network, but actually you do not know what exactly you would like to monitor. For example, as we mentioned before, as we talked before, you can monitor the packet, right? And you can monitor the execution file, for example, the PE file, and you can extract some information from the packet, from your PE files, and try to make a decision. This packet is a malicious packet or a normal packet. This PE file is a malware or not. But there's a very interesting thing that at the very first beginning, when you collect those data, you have no idea the label is, which means the target, which means the PE file is a normal file or is a malicious file. Sometimes we need human beings to help us to do labeling. This PE file is we can analyze the PE file in some other ways. For example, to do static analysis, to do dynamic analysis, as we mentioned before. So we can have a label. Okay, that is a malicious file, and it belongs to malware family A, something like that. But at the very first beginning, you don't have such kind of information. So what you can do to such kind of situation? So basically, okay, of course, there are some interesting numbers you can try to do things. Okay, so basically, we go to this one. Basically, you have several different classes, several different types of intrusion detection system. And from my point of view, if you have enough money, your company should apply most of them, because they will counter, they will try to identify, will try to detect different types of attacks. Okay, so basically I would like to show, we can find some right here. We can find some space right here. Okay, so basically my suggestion is like okay, let's take a look. Let's take the example of network. Okay, so basically that is internet, right? And you have a router, which is the first step of your protected network. Okay, so here is your protected network. Because you want to do some observation, so usually you will attach, maybe right here, you will attach a intrusion detection system right here, so that all of your traffic go through between your protected network and internet will be inspect 就是监视哈 will be inspected by your intrusion detection system. Okay. However, as I mentioned before, your intrusion detection system, okay, is simply just a monitor, right? So at first beginning, you don't have any labels. You don't know which packet is malicious packet, which packet is normal packet. So you don't, at the first beginning, you cannot apply supervised learning algorithm, right? As we mentioned before, for supervised learning algorithm, okay, you have a lot of data. For example, the data right here is the packet, okay, the packet data right here, and you can extract a lot of different features from data packet, okay, and you have Y, which means malicious or malicious. So if it is 1, that means this packet is malicious. If it is 0, that means the packet is non-malicious. However, at the very first beginning, we don't have such kind of label, right? So we cannot do supervised learning. So at the very first beginning, okay, my suggestion is if you have a system, right, and you have tons of data right here, and you sometimes want to do some certain detection project, detection task, okay, but you don't have Y. So what we can do unsupervised learning. So we can, for example, we can apply some unsupervised learning algorithm such as unsupervised learning algorithm. For example, we can do hierarchical clustering, right? We can do k-means, right? We can do a lot of different hierarchical clustering algorithms right here, okay? So if you are the engineer of this kind of design such kind of intrusion detection system, you can do unsupervised learning first, okay? So basically, we will cluster the N data into several groups. For example, we say that K groups, okay? K groups. And for each groups, okay, you can select one of the data point as the representation, or you can select some central E data point, which means that is the central of this unsupervised learning, which means that is the representation of these groups. And then you can manually analyze this specific sample and this specific cluster. So you can give the entire group a label. For example, you label this group as 1. That means after I analyze the data point in this unsupervised learning cluster, and I pick up some, randomly select some samples from these groups, clusters. Okay, we say C1, C2. Okay, for example, I randomly select 5% of the data point in cluster 1, and I manually inspect it. And we say, okay, the packet, okay, for example, the packet in the cluster C1, they look similar, okay, no matter what kind of clustering you like to use. they look similar. Okay, so so you can check it out on a Google, or you manually inspect those packets. You can make a decision. Okay, those packets, and I give them label as 1, so they are malicious. Okay, maybe the other group, you give the label as 0, maybe that is normal packet. And after that, you have labels. So then you can use a supervised learning right here. Sorry. You can make a machine learning algorithm right here. That is supervised. So that tons of algorithm can be used right here. For example, SVM, regression. What else? We have neural network, even convolution neural network, something like that. Okay, so in this case, okay, you know that those labels are created by unsupervised learning, and you should be responsible for do such kind of labeling. That means you put your knowledge, you use your knowledge to do such kind of labeling. So this supervised learning would learn your knowledge of labeling. Okay, so you can do such kind of things. And my recommendation is that you can design such kind of detection system firstly by using unsupervised learning, and you do manual labeling, and you use a supervised learning algorithm to simulate how you make such kind of decision. Okay, and of course, your decision, your labeling technique might not be perfect. Okay, so in the meantime, you always have to do such kind of things. I hope you remember the things. That is confusion matrix, right? Actual, predict. Okay, your model can predict this, right? But over the entire detection technique, you always have to do some malicious, normal. Okay, you always have to. Sometimes you have to do some samples from your network, okay, and see how many packets fell into different part of the confusion matrix. And you have to manually inspect those samples regularly. Okay, and what the reason why? Because you don't know such kind of labeling is correct or not. It's based on your expertise. So sometimes you have to sample data from your current environment and try to modify your label, okay, and to try to improve your supervised learning algorithms. Try to improve your current supervised model, something like that. Okay, so of course that is an example of we use an internet, we use a packet as an example to describe such kind of we call procedure. But for any other detection system, no matter if it is a cybersecurity detection system or not, you can do such kind of process. Okay, so there are several different types of detection systems, okay, but they are intrusion detection systems. Okay, so here, attempt to break in, masquerade break in, okay, penetration, leakage, denial of service, malicious use. They all focus on different types of, we say, intrusions. Okay, intrusion. It depends on how did you define attack or intrusion. Okay, the concept of attack is not 1 or 0. Okay, it has some degrees. Okay, maybe some attempt break-ins, they are harmless, which I mean they try to break in your, for example, break in your house, but break in your system, but they do not success because the break-in technique or the break-in tools, or you have a very nice firewall so that the hackers cannot break in with a very simple tools. But do you consider such kind of attempt break-in as an attack? It depends on how you feel. Some people believe that, okay, if you have attempt, if you do have intention to break in my house or my system, then I will consider it is an attack. As long as you want to, you send some packet or you send some malicious file to my system. But there's another kind of people. They believe that, okay, because I have a firewall, because I'm well protected by my firewall, and my firewall does not allow such kind of attempt break-in to enter my system, so that does not count as an attack. Okay, because it does not successfully break in into my system. So, but I believe those two different concepts are all correct. Okay, because they have different point of view, which is okay for me. Okay. So then, there's always something very important, is that behavior profiles. Okay, profile. We mentioned about profile before. Okay, if you have a monitor, right? If you have a monitor, you can always left some behavior traces, or we say audit data. Okay, traces. Those traces, those profiles, they can describe what is the actions, what is the packet, what is the file, what is the program has been, for example, executed in my system or been delivered to my computer networks. So before you do such kind of analysis, make sure you have proper monitors, and they can record, they can create, they can generate some traces between your system and the attacker. Okay, so make sure you have such kind of things, you have such kind of monitors. Okay, and you have exactly the same. Okay, use of system resources. Okay, you can observe, you can have a monitor to observe your system resources to make sure your resources has not been misused by the attacker, or as I say here, leakage by the attacker. Okay, again, usages, again, profiles. So the most important thing of the detection system is you have to have a monitoring system, okay, to confront, to deal with such kind of breaks. Okay. Usually when we use this word penetration estimator, it's truly infect your system, and your system has been attacked by the attacker. And when we use the word leakage, that means data leakage. Okay, denial of service is quite easy. Your system is not be able to function normally, so we call it denial of service. Your system, most of them are, for example, web service, provide web service, database services, file services, they will not be able to function normally. So the service is down. So we call it denial of services. Okay, malicious use we'll talk about later. Okay. Now, there are two different types of techniques that we can create an intrusion detection system. Okay, let's go back to here. Okay, I would like to use this one, okay, to describe it. When we say supervised learning or any other algorithms, that we like to put into this core, Okay, we simply use the word model, right? You need to have a model. Okay, no matter that it is SVM or it is a regression model, it is a neural network model, it's a convolution network model, no matter what it is a model. Okay, but how do we use such kind of model? We have two different ways. Okay, first, anomaly detection. Okay, anomaly detection. We have talked about anomaly detection by using PCA, but I think we can revisit it right here. Okay, basically a typical anomaly, make sure you quote it. Okay, anomaly detection model is like that. Okay, audit data. That means I have a monitoring system, and I monitor my system, no matter it's a computer system, it's a network system, or it is your production line, your machine. No matter what it is, you have a monitor system, and it can produce the traces of your system. Okay, so at the very first beginning, you collect those audit data. Okay, and you can create a profile for your machine, for your network, for your computer system, for your software, no matter what it is. Okay, you can create a profile for it by using the audit data, the monitor data you collect from the monitoring system. Okay, at that time, okay, you have to make sure your system is not under being attacked, which means your system currently works normally. Okay, I will say it again. If you would like to create an anomaly detection system, first you need to have to collect some data. When you collect those data should be collected under a situation that your system is not being attacked, which means it's normally operated. Okay, so basically we have normal data. Okay, then we say you have to create your model, which means the profile. So you have to first, second, you have to create your model. Okay, since the model is created from normal data by using normal data, so you have to create your normal data, normal model. Okay, so so you have a model. Okay, you have a model. This model describes how normal data is represented, and then okay, you go into the testing phases. Okay, you collect data. You collect those data no matter if it is under attack or it is not under attack. Okay, you simply just collect data. Okay, so you have a model here. So model, we say it is model. Okay, and you would like to create a lambda. Lambda means detection. Detection consists of several things, including a model and a D. That means that is model. And that's D is distance function. What does that mean? When you collect data and you perform detection, okay? Since you have the normal model, right? So when you collect the new data, you can compare your new data against with the normal model you created by using normal data. And you have to define a distance function. Okay, we have talked about this function many times. For example, it could be Euclidean distance. It could be Manhattan distance. It could be cosine similarity distance, cosine distance. It could be Jakarta distance. There are several different distance functions can be defined by you, or some can already define several different distance functions. Okay, so you have your normal data to build your normal model, and you have your new data, and you can check against it with your new data with the normal model and see if the distance function can output. Okay, your current data is a little bit far away from your normal model. So basically we can draw it by, for example, we can draw it in this way. For example, we have two features right here, and we have several data points right here, right? And I say, okay, that is normal data point, and I can create such some kind of representation to represent this circle. So maybe I can create, for example, I can use neural network. Okay, I can draw a boundary line right here, right? I can draw a boundary line no matter what kind of neural network you want to use, but you can use neural network to draw a boundary line in the original space, right? So that is the boundary line. Okay, maybe from your all neural network. Okay, so here there might be a new data point right here, a new data point right here. If the new data point is right here, that means new points right here. So you can set a distance function. You say, okay, this distance function means if you fell out of my boundary line, boundary area, then you are malicious things. You are anomaly. You are an anomaly. Okay, you are, if you were within my boundary line, which means we set up a distance function, and your distance between our data and your new data is less than certain value. Okay, so you can define your distance function. Then I say, okay, then you should be familiar. You should be very, very familiar with my normal data. So I consider you are the normal ones. You are not malicious ones. So that is quite simple. That is called anomaly detection. So what is the problem of anomaly detection? Okay. What is the problem? Normal data. First, when you create such kind of normal model, you have to guarantee your data to create normal model is truly normal data. Because sometimes, for example, you're a company, you have a network, okay, and you are the you are the network administrator. You want to set up a very nice anomaly detection system, and you set up the monitors. You capture all the packets between your network and the internet. But when you capture those data, those packets, can you guarantee those packets are all normal? Actually, you can, because even at the very first beginning of even at the first day of your company, your work day, maybe your employee may bring his or her laptop into your company, and maybe his computer is infected. So the very first time when you collect the packet in your network, those data are dirty, which I mean those data are not all normal data, because some careless employee may bring his infected laptops into your company. So the data collection fails because you collect some dirty data. So if you use that dirty data to create your normal model, your normal model may not be that accuracy, right? First thing is the normal data. The second thing is the normal model. What? That is the only two things we talk about, right? So what is the problem of normal model? When we do modeling, okay, there are some problems. For example, if you would like to design such kind of things like here, as we mentioned before, what kind of information you should keep in your model? Actually, I don't know, because Packet has a lot of headers, a lot of payloads. For P files, there are a lot of headers, a lot of sections, a lot of bytes, which I don't know if it is very useful or it is meaningless to detect something that, for example, malicious or non-malicious. So creating a model is not a good. It is not easy. Okay, it is not easy, right? Okay, and so I think that is the how do we describe a system called anomaly detection system? Okay, so what actually we use to right here to describe anomaly detection system to truly create a system. Maybe I can write in right here. Okay, as we mentioned before, of course there are several different ways. Okay, for example, if we use neural network, okay, we talk about new autoencoder, right? And I give you some links to autoencoder, right? So basically you can see it in this way. Okay, we have several features and we create an autoencoder. Okay, we have key, right? And autoencoder looks like this, right? We have a decoder, we have an encoder, we have a decoder right here. And then, as I mentioned before, of course, our loss function is right here. We would like to see if the hidden layers can correctly decode the data to x1 prime, x2 prime, and they should be very, very similar to original x1 to xn. Okay, that is autoencoder, right? Encoder. So we can use autoencoder. Okay, so that is the important thing, is that we believe this length space can correctly model, okay, the original data set, data point. Because this length space can decode to the original data very well. So all information of x1 to xm is preserved in h1 to hk, right? That is the definition of autoencoder. So we can do such kind of things. Okay, so if there is an anomaly data, so this autoencoder, okay, they of course they have learned. They have learned all those n datas. So this autoencoder, those weights, right? They know how to convert x data to h data and go back to x prime data, right? So as we mentioned before, if there is an anomaly right here, okay, we use another color. Okay, there's an anomaly point right here, and you fit them into this weight, but this weight has not been this weight when we do such kind of this encoder and decoder, the anomaly data has not been seen by this weight, so this weight does not tuned before, because this weight are tuned based on this green data point, not the anomaly data point. So this anomaly data point will not be correctly decoded back to x1 to xm. So that in this case, we can always set a distance function right here. Okay, as I mentioned before, as I mentioned right here, you can always set the distance. So here, the model right here is exactly those weights. Those weights are the models that can convert the X data by using the encoder to H data, and can decode the H data to X prime data, and make sure the X prime data and the X data would be very similar, because that is how we actually autoencode to do. However, if there is a data, you pass it into the encoder and then decode it. If the distance between the X prime and X data, they are far away, which means you have to define a distance function, then that means, okay, this model has not seen such kind of anomaly data before, so this model cannot correctly do encoder and decoder. So that's called detection, anomaly detection. Okay, so that's one of the way we use the, for example, that is a neural network to do such kind of anomaly detection system. Okay, so again, you have to define what kind of, again, right? First, you have to define a set of normal data, which is green data right here, right? The normal data, which is the green data right here, that is normal. Make sure that all those data are normal. Okay, you don't have to, you don't want to mix any abnormal data into this data set. Okay, and you create a normal model. Here we have an example which is autoencoded, which is very nice, and we collect the new data, which is the purple data, anomaly data, and we do such kind of detection. All right, so that is one of the way we use neural network to describe the original typical anomaly detection system. Okay, the concept is the same. We just use a mathematical way to describe it. Okay, and that is the other one, misuse detection. Okay, we have talked about misuse detection maybe at the second week in our class. Okay, so misuse detection means, actually I don't want to model normal, because normal is normal, because I don't know what normal is. So some detection system, they model so that first collect attack, or malicious. The different thing is that we don't collect normal data. We collect attack data or malicious data, whatever. Because from the perspective of human beings, okay, it is more easily, okay, if there is some problem, because every day, okay, you collect a lot of packet, or you collect a lot of files, you collect a lot of traces. There are tons of data, and it's not very easy for you to analyze those tons of normal data. But attacks does not always happen, so it's more easily for you to collect those malicious data, because it is rare, and it happens. You know it happens sometimes. Okay, so you can collect those data and you model such kind of attack. So the philosophy is a little bit different. In the previous one, we collect normal data, we model the normal data. But right here, we collect attack data and we model the attack data. And the next one is exactly the same. Okay, we compare the attack model with current trace. Well, since we have a model can describe what is an attack, And currently we have new traces. So we check it against with the attack model. If it is very similar to the model we create before, then the new traces contains certain attack because it is similar to the attack. If the current trace is far away from your attack model, then we believe, okay, then this current dataset does not similar to the known attack. So it is not known attack. Okay, so did you see what is the problem of this attack model? It's right here. If we collect attack which is known to us, then the model we create is known attack model. But attacks sometimes, okay, they are very sophisticated. They will be the new attacks. So when we check against it with the known attack model, we can only identify known attack, which means if there's a new traces right here, it is actually a new attack. But when you check against it with the known attack model, then again we have model here, we have distance here, right? This model can only identify known attacks. So as I mentioned before, most of the time, okay, you have to right here. Most of the time, maybe once a week or once a month, you have to check against your system again. You can sample some attacks. You can sample some your data and check against with your knowledge manually, so that you know, okay, currently my model is good enough. This model can deals with the current attacks, current normal models. There's no new attack or no new normal models has been observed, so that my model can performs well. But if you observe any thing right here, that means your model is not good enough. So you have to retrain your model. You have to collect the new data to represent a new situation, new attacks, new normal behaviors, so that your model will be much better when you upgrade, when you your things. But we have to, but there's some very interesting and useful things for the misuse detection system is that if your model is good enough, every time the attack, the known attack, comes into your system, your model can capture it. So it has a very high accuracy to detect known attacks. Okay, so so basically, of course, we can write some neural network like this. Okay, we still have some features right here, right? And some hidden nodes right here, and we simply just if you have label such like, okay, that is attack or that is not attack. If you have such kind of very nice label, you can do such kind of neural network. But most likely we don't have such kind of label. So sometimes we simply just do misuse detection, or sometimes we simply just use anomaly detection. But most of the time, okay, as a network expert or a network administrator, my recommendation is that your system should have at least one misuse detection system and at least one anomaly detection system. They can cooperate with each other so that misuse detection system can monitor known attacks, can detect them with very high accuracy. On the other hand, if you have another anomaly detection system, they can just keep trying to model the new normal model. And if there is something wrong with your system, which is not comply with your normal model, then your anomaly detection system can stand out and says, okay, there's something that I don't know before. It does not look like normal behavior that I observed before. So I raise an alarm. So as a network, if you are a network administrator in the future, sometimes you have to take those things into account. Okay, it's 12 o'clock. We stop right here. We will not go through all the other things. At the end, at the bottom of this paper, okay, it talk about several different ways to create your kernel function. But as I mentioned before, you can use a very simple autoencoder to do anomaly detection. You can use a very simple neural network to do misuse detection. Of course, there are some other old ways. For example, you use a statistic approach, you use a prediction approach, you use a Markov chain, something like that. But currently, we don't do those things anymore. Yes, we don't do these things anymore because we believe that neural network or some deep learning mechanism or machine learning mechanism, they have better capability to transform the observed data to the target. Okay, so there are some old stuffs, but I think they're still good enough. There are still some fundamental things that you should know. Okay, you should know. But basically, we use neural network, right, or some machine learning algorithm in some modern intrusion detection systems. Okay, that's it. Okay, we stop right here. Let's go back to here. Okay. Since you, I believe you have a hand in your because it is it is June 3rd, right? So I believe you have hand in your final project proposal today. So make sure you have done this before. You have already done this, and you have I think we have another homework, right here, which is homework number 5. So I didn't not give you homework last week, but today I will give you a new homework since you have hand in your proposal and your homework number 5. Okay, so homework number 6 will be announced today. So make sure you continue your project and don't forget your homework number 6. Okay, that's it. So we stop right here, and I think that is it. We will give you some homework which is related to intrusion detection. Okay, so make sure you understand what exactly intrusion detection is. Okay, goodbye. That's it.